Okay, here we are on page 4, continuing with the chain rule. So for this one here, we can see that the composite function, the inside part, is this part, right? And we can see that if we group everything that's in the red circle, basically it's in the power rule format, right? 6u to the third. So it's easy to take the derivative of this. It's 18u squared, right? So we can go ahead and do that. We can do here 18u squared, but actually u is like what's in here, right? And then we can simply take the derivative of what's inside here, du dx, and we're done. Okay? So even though there's like this complicated thing inside the regular format for the power rule, all you need to do is copy it to here and then take the derivative of it and you're done, and multiply it. Okay? Because the chain rule says dy dx is equal to dy du times du dx. Alright? Moving on. Let's look at G here. So this looks like this is the composite function inside part. So let's rewrite this so that it's all in the numerator. It makes it easy to take the power rule. So we're going to have the derivative, so we're going to have 6 times negative 2, and then we just copy this down here, the inside part. And then we're going to reduce this exponent by 1, so it'll be negative 3. It's not negative 1, remember. And so this would simplify to negative 12 here, but we are missing something, which is we need to take what's inside here and take the derivative and multiply it times that. So the derivative would be 5, right? Because the derivative of 5x is 5, the derivative of 4 is 0. Okay? So we have a multiplication by 5 there, and so to multiply it all out, it would be negative 60, which is negative 12 times 5, equals that. Okay? Alright. Let's look at this one. So it looks like we can do the power rule as long as we treat that as, the u. So let's see. If we could take the derivative of that, be careful, don't write an equal sign because the derivative is not equal to the function. Sometimes I draw an arrow just to show I'm taking a derivative. So here I will have 6x squared minus 2 over x, and then I'm going to multiply it times the derivative of the inside part. Ooh, now this derivative of the inside part is a little bit tricky, so I'm going to write it right here. X squared minus 2 divided by x. The derivative of x squared, of course, is not tricky. It's 2x. The derivative of 2 over x is a little bit tricky because it's got a x in the denominator. We're going to rewrite it as 2x to the negative 1. Now the derivative of this would be 2x to the negative 2. Okay? So now we know the derivative of x squared minus 2x minus 1 is that, so we're going to copy it right here. 2x plus 2x to the negative 2. And that is the answer. Okay? Alright. Number 3. Find the gradient of the tangent to, and remember, gradient of the tangent is just another way of saying derivative. But in this case, they're asking for it at a certain point, like x equals 1/2. Okay? So, first thing we're going to do is take the derivative of that. We have 1 minus x squared to the 1/2. I rewrote it so it's easier to do the power rule. We take the derivative. It's going to be 1/2, 1 minus x squared, and then the exponent is going to be negative 1/2 because we have to subtract 1 from 1/2, right? My 2's don't look too good, do they? Okay. Now, one thing remains. We need to do the chain rule. So what's inside here needs to be differentiated also. The derivative of 1 is 0. The derivative of negative x squared is negative 2x. Now, they want to know the derivative not in general, but they want to know it at x equals 1/2. So I need to plug in 1/2 in for this x and this x, and let's see what I get. This is going to be a little bit complicated, so bear with me. We're going to have 1/2, 1 minus 1/2 squared. And 1/2 squared is 1/4. So I'm going to put 1/4 there. To the negative 1/2. And then I multiply all that times negative 2 times 1/2, which is negative 1. Right? Negative 1/2. Negative 2 times 1/2 would be negative 1. Okay. Now, I'm going to do this part. This is going to simplify to 3/4. And then a 3/4 to the negative 1/2. And then I can put this negative 1 and 1/2 multiplied together in front. It would be that. And remember that the negative sign here, it just means that you're inverting what's inside. So instead of the way it's written here, just to get rid of that negative sign, I'm going to invert 3/4 to 4/3, and then I'm going to have 1/2. And then I'm going to take the square, because 1/2 to the power of 1/2 is a square root. So I could say, oh, the square root of 4/3 is 2 over square root of 3. And then I'm going to multiply it times negative 1/2. So the 2's cancel out, and I end up with negative 1 over square root of 3. Okay, so after all that work, that is the gradient of the tangent, okay, for part A. Okay, what about C? So first I'm going to take the derivative of that. I'm going to work down here. Okay, so for C, first thing I'm going to do is rewrite it so that it's all in the numerator. And then I'm going to take the power rule and the chain rule. So it's going to be negative 4 times 2x minus 1 to the negative 5th. And then I'm going to multiply that times the derivative of the inside, which is 2, right? Because the derivative of 2x is 2 and the derivative of negative 1 is 0. Now it's going to be negative 8 times 2x minus 1 to the negative 5th. Okay, now I'm just going to plug in x equals 1. Oh, thank you for not making it so complicated this time. So negative 8 times 2 times 1 is 2 minus 1 to the negative 5th. Okay. Yeah, they really made it easy on me this time. 8 to the negative 5th. Now remember, 1 times itself, 5 times, even if it's inverted, is still going to be 1. Okay, so this is 1 to the negative 5th is the same as 1 over 1 to the 5th. 1 to the 5th is 1. So 1 over 1 is 1. 1. Okay, so it's just, you multiply 8 times 1 and you get 8. Alright? Alright, let's go to E. So E, I'm going to rewrite it so that it's all in the numerator again. So it's going to be x plus 2x to the 1/2, because square root is 1/2, is negative 1. And then I'm going to take the derivative. If I take the derivative, it's going to be 4 times negative 1, which is negative 4, x plus, and I just write the inside exactly like it was. And then the exponent to the negative 1, now it's going to be negative 2, because I subtract 1 from it. And then I take the derivative of the inside, which is going to be derivative of x is 1. The derivative of 2x to the 1/2 is 2 to the 1/2 x to the negative 1/2. Alright? Alright, and now I'm going to plug in x equals 4. When I plug in x equals 4, this is very messy, isn't it? But at least they give me a number like 4, which is going to have a square root, so okay. I'm going to rewrite it here. So, let's see, it's going to be negative 4, and x is 4, plus 2 times square root of 4, which is 2. So it's also going to be 4 to the negative 2. Then I multiply that times, let's see, I'm going to do 4. What's the, if I put 4 in for this x here, first I take the square root of 4, and I get 2, and then I invert it, so I get 1/2. So then I have 2 times 1/2 times 1/2, okay? 2 times 1/2, and this would also be 1/2, because when I put 4 in there, it's going to be the square root, which is 2, and then I invert it. So it will be 2 over 4, which is 1/2. So in here I'm going to have 1 plus 1/2, which is just 3/2. Okay, so I'm going to put that afterwards. 3/2. which is equal to, we can cancel this 2 with this 4, and we get 2. So we have negative 6. If I multiply the 2 and the 3 together, I get negative 6. 4 added together is going to be 8, so I have 8 to the negative 2. And 8 to the negative 2 is 1 over 8 squared, which is 1 over 64. So I'll have negative 6 over 64. And then here I could factor out a 2 out of both to get at least, to reduce it. And then I'll have like negative 3 over 32. Very likely that I might have made a mistake there, right? Okay. Just on the arithmetic. Okay, the gradient function of f of x equals 2x minus b quantity to the a power is f dash blah 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 blah. Okay. Find the constants a and b. Okay, so this is just a, they try to make it more complicated by giving you variables, or constants, but don't let that fool you. Okay? So, first of all, just like you can take the derivative of that, even if it's not exactly like you're used to. It's got some a's and b's in here, but just treat the a and b like it's a number. Okay, so you're going to say, okay, I'm going to bring the a out front because it's a constant. If it's a variable, you can't do that, but it's a constant. And then I'm going to take 1 and subtract it from a. And so that is the derivative of 2x minus b quantity to the a power. Now I am going to, and then the other thing I need to do is I need to take the derivative of that and multiply it times at the end. So it's going to be 2, right? Because the derivative of 2x is 2. The derivative of b, if it's a constant, is 0. So, okay. And now we can set it equal to that because they said it's the same thing. So this is just a combination of a chain rule problem and, an algebra problem. And let's see if I can simplify this left side. 2a times 2x minus b, a to the minus 1. Okay? And it's equal to this. And they don't look alike at all, do they? Now, how could I make this look like this? Well, you can see that this looks like a quadratic or something. And this is a quadratic. So if we factored it, maybe we could get it to look like this. Okay, so let's try to factor it. So maybe to make it a little easier, we factor out a 6 first. So we'll say, okay, 6 factored out, so we'll have 4x squared minus 4x plus 1. And then we're going to factor out this part. So we're going to have 2x minus 1, maybe? Squared? Let's see if that works. FOIL. Negative 1 squared is 1. Okay, that one works. 2x squared is 4x squared. That one works. Okay, let's do OI. So you multiply negative 1 times 2x, you get negative 2x. You double it, negative 4x. Okay. So it worked. So, okay, now we compare this to this. So 6 is 2a, right? Because those are, corresponding parts of the equations. So a has to be 3, right? What else? This, 2x minus 1, is 2x minus b. So b is 1. And last of all, a minus 1 is 2, which means that a is 3. And that confirms what we had for a. So that's it. Last one, number 6. If y equals x cubed, then x equals y to the third. Yeah, that makes sense. One is an inverse of the other. Find dy dx and dx and dy and show that dy dx times dx dy equals 1. Oh, that's interesting. Okay, so first let's find dy dx for this. We're just going to take the derivative, 3x squared. Okay, then we're going to find dx dy of this. We're going to take the derivative with respect to y. So now it's going to be 1/3 y to the negative 2/3. So we have this, which is dy dx, and we have this, which is dx dy. We're going to multiply them together and see if we get 1. So if we multiply these two together, then the 3 and the 1/3 give you 1. Okay, so far so good. Then you take x squared and you multiply it times y to the negative 2/3. That didn't give us 1 yet. But what if we put the x or the y in terms of each other? So we know that y is equal to x cubed. So let's substitute y equals x cubed here. So we're going to have 1 times x squared, and y equals x cubed. So we're going to put x cubed in for y here, and it would be like that. Now we're going to multiply everything out. So x to x cubed, and then you have a 3 here, and these kind of cancel out, right? Then you end up with x squared x to the negative 2, and that is equal to x to the 0, which is 1. So we showed it.